This is GCSE Physics, Electricity Lesson 17, and this is Electrical Energy Part 2. So we're going to use the two power equations which we've used previously and produce the third equation, and then apply the new equation to physical problems. So let's do an equation recap. We've got the energy is power times time. Remember, energy is in joules, power is in watts, and time is in seconds. Now the other equation which we've just used is P equals IV. Power again is in watts. I is current, and current's measured in amps, and V is voltage measured in volts. And what we can do is combine these two together. So we've got E equals P times T, power times time. But then we've also got power is current times voltage, and we can substitute that into there. So what we end up with is energy equals, and we've got I times V times T, or as I like to remember it, ITV. Doesn't matter what order the ITV or TIV or VIT, it doesn't matter at all, because obviously they're all multiplied by each other. So E is energy, as we've already said, measured in joules. I is current in amps. T is time in seconds. And V is voltage in volts. Okay, let's move on. Let's do a quick recap question practice. So if we just pause and have a go at this one. Calculate the energy used in joules by a hairdryer of power 1.2 kilowatts in 1 hour. So we'll go for the answer now. So we need energy. So energy is power times time. And the power is 1.2 kilowatts, so 1,200 watts times, and we've got 1 hour. So we've got 60 minutes times 60 seconds to give us 3,600 seconds. So we're going to times by the 3,600 seconds. Put that in your calculator. And we get 4,320,000 joules, or 4.32 megajoules of energy. Okay, let's move on. So just to reiterate, electrical energy, IVT or ITV, whichever order you want to put it in. So just to make sure that you've got that, and then we're going to apply this to some questions now. So calculate the energy used in joules by a 12-volt car starter motor when drawing a current of 85 amps for 4 seconds. So if you want to have a go at that one, and I'll take you through the answer now. So energy is equal to ITV. And then we just simply need to put the numbers in. So the current is 85 amps, multiplied by, it's going for 4 seconds, and the voltage is 12 volts. So if you put them in your calculator, it gives us 4,080 joules of energy. Let's try a different one. So this one's a little more complicated. If you want to pause and have a go. Calculate the current drawn from a device that transfers 10 kilojoules of electrical energy from a 1 kilowatt supply in 1 minute. So the equation is E equals ITV. And if you're confident with the maths, we can just rearrange to find current straight away. So we've got a times T and a times V, if you want to make I the subject. So to get rid of a times T and times V, we need to do energy divided by times time and voltage to give the current. Then you can just put your numbers in. Probably the best way to do it, actually. So then you can just put the 10,000, the time is 1 minute, and the voltage is 1 kilovolt. The other way is to put the numbers in, which you can do. We'll do that now. So energy is 10 kilojoules, so 10,000 joules, equals the current, which we're looking for, I, and then we've got T times V. So we can actually multiply those two together. So the voltage is 1 kilovolt, which is 1,000, multiplied by 1 minute, which is 60 seconds. So essentially we've got 10,000 equals the current times, and 1,000 times 60 is 60,000. Then to get current on its own, make it the subject, we need to get rid of the times 60,000, so it's just simply going to be 10,000. The opposite of timesing is dividing by 60,000, which gives us 0.17 amps. The other method on the left I do prefer. So for the next ones, I will rearrange the equation first, then put the numbers in. So let's do 2 more examples. By 2, I mean this one and then a table. So if you want to pause and have a go at this one. So this one says calculate the time taken for a device to transfer 1 megajoule, which is million, of electrical energy from a 2 kilovolt supply, which is 2000, with a current of 2000 milliamps. So to go from milliamps to amps, we need to divide by 1000, so that's just 2 amps. Let's pop that there. Right, so equals ITV. So we need to find time, so we need to get rid of a times I and times V. So the opposite of times in by I and V is dividing by I and V. So energy divided by IV will give us the time. So then we just need to put our numbers in. So the energy is 1 million divided by the current, which is 2, times the voltage of 2000. So 2 times 2000 is 4000. Then we just simply need to put that in our calculator. And that's 250 seconds. Hopefully that went okay. Now we're going to the table. For the table, you're going to need to use the different equations. So it's good practice. So you want to pause and do those calculations. So there's 8 to do. And then I'll take through the answers. So the first one, power, we can do P equals IV. I'll just jot the equations. You've got P equals IV. We've got energies, power times time. And if we need it, we've got the E equals ITV. So the first one, P equals IV, so we've got 10 times 5, so that gives us 50 watts. Then we've got energy, we can do ITV for that, or power times time. It's completely up to you, they'll give you the same answers. So 50 times 4 gives us an energy of 200 joules. Let's look at the next one. So we've got P equals IV. So let's do a little bit of working out. So we need to do current is power divided by voltage. So it's 100. Let's write this down. P over V. So it's 100 divided by 50, which is 2 amps. So for this one, we can just do energy is power times time. So time would be energy. We need to get rid of the times P, so it'd be divided by P. So energy divided by power. So the energy is 800. Do this one down here. Energy is 800 divided by the power of 100, which gives us a time of 8 seconds. For this one, we've got the energy is power times time. So power will be energy divided by time. So we've got the 450 for the energy divided by the time of 5 seconds. So that gives us 90 watts. So that was 90 watts. And then we can just use P equals IV to get the voltage. So to get the voltage, we need to get rid of the times I, so divide by I, so it will be 90 divided by 3. 90 divided by 3 gives us 30 volts. For the last one, we've got P equals IV. So the current is power divided by voltage. So we've got 2 kilowatts, which is 2000. Let's put this here. So 2000 divided by the voltage of 250. And if we calculate that, we get 8 amps. And last but not least, we can use energy equals ITV, or energy is power times time. So I'm going to use power times time. So the power is 2000. I'm going to put this at the bottom. 2000 watts times the time of 3 minutes, which is 180 seconds. Which is equal to 360,000 joules, or 360, in fact I do that, 360,000 joules, or 360 kilojoules. Hopefully you found that practice useful. You've got a new equation as well. So thanks for watching, and I'll speak to you soon.